Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P0714 indicates an intermittent failure in the CVT fluid temperature sensor, specifically related to its electrical circuit. This important sensor plays a crucial role in monitoring the temperature of the continuously variable transmission fluid, which is vital for ensuring optimal transmission performance and longevity. Located near the transmission fluid pan, the sensor provides real-time data that enables the transmission control module, TCM, to make necessary adjustments to maintain the correct fluid temperature. If the TCM detects that the temperature readings from this sensor are not accurate due to intermittent electrical failures, it will trigger the DTC P0714. This code is not indicative of mechanical issues with the transmission itself, but highlights electrical circuit problems. Proper diagnostics are necessary to assess the sensor and its connections, ensuring that the transmission remains in good working order. The CVT fluid temperature sensor is a critical component that helps maintain the efficiency of the vehicle's transmission system. By monitoring the temperature of the continuously variable transmission fluid, it informs the TCM about any necessary adjustments in real time to prevent overheating and ensure smooth operation. This sensor is strategically placed near the transmission fluid pan to accurately gauge the fluid's temperature. In a well-functioning system, the readings provided by the sensor should be consistent with the ambient air temperature, particularly during initial diagnostics. When discrepancies occur, such as those indicated by DTC P0714, it points to an intermittent failure within the electrical circuit of the sensor rather than a mechanical fault in the transmission itself. Therefore, understanding the role and place of this sensor helps technicians effectively diagnose issues impacting vehicle performance. The DTC P0714 can arise from a variety of possible causes, all related to electrical issues rather than mechanical faults. Firstly, faults within the electrical circuit that connects the CVT fluid temperature sensor to the TCM can lead to intermittent readings. As this DTC signifies an electrical anomaly, any broken or frayed wiring must be investigated. Secondly, the sensor itself may be faulty, either due to internal wear or manufacturing defects that cause incorrect readings. It's also essential to examine the connectors and terminals associated with the sensor, as loose or corroded connections can disrupt the flow of accurate information, leading the TCM to misinterpret the actual fluid temperature. Identifying these possible causes is critical to clearing the DTC and restoring the vehicle's performance. When DTC P0714 is triggered, several symptoms may indicate that the transmission is experiencing issues related to the CVT fluid temperature sensor. One common symptom is harsh shifting, where the transmission struggles to change gears smoothly due to incorrect fluid temperature readings. This can lead to a decrease in drivability and comfort while operating the vehicle. Additionally, poor fuel economy may occur as the transmission might not operate efficiently when the sensor fails to provide accurate temperature data. Finally, the check engine light will illuminate on the dashboard, serving as a clear alert that there is an issue impacting the vehicle's performance. Recognizing these symptoms is critical for timely diagnosis and repair, ensuring that the vehicle remains safe and reliable. The first step in troubleshooting DTC P0714 involves checking the current transmission fluid temperature. To begin, turn the vehicle to the on mode, allowing the vehicle's systems to power up. Utilizing the Honda Diagnostic System, HDS, you will then monitor several parameters, including the CVT fluid temperature, CVTF, and engine coolant temperature, ECT, sensor 2 readings. It's essential to compare these values to determine if they are equal to the ambient air temperature. If they are equal, you can proceed to the next troubleshooting step. If not, document the CVTF temperature readings before moving on to the subsequent tests. This step is crucial for establishing a baseline for further diagnostics and pinpointing whether the issue lies within the sensor or its circuitry. In the second troubleshooting step, the goal is to assess the difference in CVT fluid temperature over time. Start by turning the vehicle off and waiting for a minimum of 30 minutes. This waiting period allows the system to cool down, creating a better opportunity to capture accurate temperature readings. After the wait, turn the vehicle back to the on mode and use the HDS to compare the current CVTF temperature with the temperature recorded in the previous step. It is important to check whether the CVTF temperature has changed. If it has, the next step is to leave the engine off for at least 6 hours before proceeding to further validation. However, if there is no temperature change detected, it indicates an issue with the transmission fluid temperature sensor, and the solenoid wire harness A will need to be replaced, addressing the root cause of the DTC. The third step focuses on conducting a comprehensive check of the transmission fluid temperature sensor. To accomplish this, compare the CVT fluid temperature readings with those of ECT Sensor 2 from the data list available through the HDS. It is crucial to assess whether the CVTF temperature is significantly higher by 58 degrees Fahrenheit, 32 degrees Celsius, or lower by 43 degrees Fahrenheit, 24 degrees Celsius. Compared to the ECT sensor readings, if either of these conditions is met, it confirms a fault in the transmission fluid temperature sensor, warranting a replacement of the solenoid wire harness A. However, if the values are consistent and do not show these significant discrepancies, it suggests that the temperature sensor is functioning correctly at that moment. At this point, the technician should check for PAR connections and loose terminals in the wiring between the temperature sensor and the TCM, as intermittent failures could still be at play within the system. After completing the necessary repairs associated with DTC P0714, it is vital to conduct a final verification to ensure that all issues have been resolved. Begin by performing a test drive of the vehicle under various operating conditions to assess its performance. Monitor how the vehicle shifts and responds to acceleration, as these factors will give insight into the transmission's operational status. During this process, keep an eye on the dashboard for any reappearance of the check engine light, as it may indicate remaining fault codes. Finally, utilize the HDS to scan for any DTC codes that might still be present. If DTC P0714 or any new codes appear, additional diagnostics may be necessary to identify residual issues, ensuring that the vehicle is returned to its optimal operational state. Preventive maintenance is crucial in avoiding future recurrence of DTC P0714. Start by regularly checking the condition of the CVT fluid temperature sensor, focusing on any signs of wear or damage. Additionally, routine inspections of the electrical connections between the sensor and the TCM can help ensure that they remain securely fastened and free from corrosion, which can lead to intermittent signal failures. Maintaining appropriate levels of CVT fluid is also critical, as low fluid levels can skew temperature readings and adversely affect the entire transmission system. By proactively addressing these aspects, you can greatly reduce the likelihood of encountering electrical circuit issues in the future, preserving the longevity and performance of the vehicle's transmission. In conclusion, the DTC P0714 highlights a specific electrical issue relating to the CVT fluid temperature sensor rather than indicating mechanical problems within the transmission. Understanding the functional significance of this sensor and its role in facilitating optimal transmission performance is vital for effective troubleshooting. The diagnostic process includes comprehensive checks and comparisons of temperature readings to diagnose correctly. Preventive maintenance practices, such as regular inspections of electrical connections and the sensor itself, alongside maintaining optimal CVT fluid levels, will significantly aid in preventing future occurrences of this DTC. By following these guidelines, technicians can ensure that customers' Honda CRV vehicles remain reliable and efficient, enhancing overall driving satisfaction. Please like and subscribe to the channel. See you next time.